Mario Modesto-MATA, thanks so much for coming back onto Evolution Soup all the way from Spain. You are a paleoanthropologist combining data analysis with dental anthropology of the Atapuerca hominins, analyzing fossil finds from the famed Sima de Los Huesos, as well as other chambers from the Atapuerca Mountains. Welcome back to the show, Mario. The good news is you're finally continuing your research back at the National Center for Research on Human Evolution.
Thank you, Mark. I'm very glad, I'm very pleased of being here again, spreading the word of the Atapuerca discoveries in the recent years and also in the past year. So it's always an honor for me.
Last time, we discussed the hominid known as Homo antecessor, fossils of which were found at the Grand Dolina site in Atapuerca in 1994. Today, we're going to be taking a deep dive into the fossil site known as the Sima de los Huesos, or Chasm of the Bones, which has given up more specimens than any other ancient human site. But before we start cataloging those specimens, can you tell us the story of the discovery of this site?
For sure. So actually, Atapuerca, it's a very small hill, but it has like around 5 kilometers of caves inside. It is very well known from the 19th or even 18th century that these caves were having inside different fossils. So, and it was also very, very familiar for the boys in those centuries to go inside the caves, pick up fossils from birds, and give to their as wedding gifts to their future wives. So that's why this was something which was very typical in this area. And at the time, so back in the 20th century, there was a PhD student at that time, which was named Trinidad Torres. He was particularly interested in studying birds, fossil birds, and he knew this story. So he came into this case of Atapuerca. He went to the Sima de los Huesos inside these 4 kilometers of caves, and he was excavating and extracting different fossils from birds. The surprise during his PhD is that among all of those dozens of fossils from birds, not only these animals were identified, but also there was a small fragment of mandible of a human. So he didn't know if it was ancient enough to be interesting. So he picked that fossil and he drove the fossil to Madrid, where his PhD supervisor, Emiliano Aguirre, the former director of the Atapuerca sites, well, actually he was his supervisor. So he was Emiliano, an expert in paleoanthropology in human fossils, and he instantly identified that that mandible without a chin was very, very old. And that was the very first human remain discovered at the Sima de los Huesos site.
The Atapuerca site has been a mecca for archaeologists and paleoanthropologists ever since that first hominid was identified. So what about the site itself? How many chambers have been found, and what are some of the treasures that have been unearthed?
Sure. So Atapuerca, the key point of this small hill, geographically talking, is that it has a very vast number of different archaeological sites and paleontological sites that they were formed in different time ranges, time periods. So the good point in here is that by combining more than 180 different archaeological sites that we know today that they are, so we can complete the full human history in Europe from 1.4 million years until now. In this sense, we can talk about important sites at Gran Dolina with Homo antecessor, Cima del Elefante with first Europeans with back 1.3, 1.4 million years old, and also Cima de los Huesos, the one that we are talking in this moment. So Cima de los Huesos is a very small chamber that to get inside to that very small chamber, we need to root inside the cave around 500 meters, and then there is like a very deep pit of 14 meters, and in that remote part of the caves is where we can find the Sima de los Huesos fossils. In chronology, we know that this accumulation of thousands of fossils, not only from humans, is around 430,000 years old, so more or less 500,000 years.
Okay, let's focus our attention on some of the amazing discoveries of the Sima de los Huesos fossil site. But before we look at individual finds, can you give us an overview of just how much was pulled out of this site? Because we're talking thousands of individuals, isn't that right?
Well, I would say that instead of thousands of individuals, I would say thousands of human remains. And that doesn't mean there are thousands of different specimens in the site. I wish there were thousands, but not so far. In any case, so it's true that from the 70s of the previous century, we discovered inside that small chamber more than 8,000 different human remains that they belong to at least 29 different individuals of the Middle Pleistocene, precisely this 500,000 year period. So, and importantly is that by studying the geology of the site, we know that these different individuals, they formed an uniform group. So they are not belonging to different layers, so therefore they are belonging to different time periods, but quite the opposite. So they all belong to the same biological population. And that's very, very important because we can get information regarding their paleodemography. In this sense, we know that concerning the ages, most of these individuals range between 15 years old to 30 years old. Concerning females, we also know that more or less half of these samples were belonging to males and the other half to females. So it's like 50-50 in comparison. And also concerning that we have more than 8,000 fossils, all of the bones of the body, of the skeleton, are represented, from the long bones like femur, humerus, to the skulls like the famous Miguelón or skull number 5, and also, and more interestingly, the smallest bones in the body, which are basically the ossicles from the middle ear. So we discover some of these fossils also in the sediment of this small chamber. And if we go to discern how is the morphology of these individuals, we know that by studying the long bones of the skeleton, so we know that the average height of these individuals were about 170 or 80 centimeters. So actually they were very tall, back 500,000 years old. And concerning the weight, they were more robust than ourselves, than Homo sapiens. So the average weight of this population was between 80 to 100 kilos without fat. So you can see that this quantity of fossils from all of the parts of the skeleton can give us a very big picture and a very confident picture of how this population was regarding demography on the one hand and also regarding morphology on the other. In the same way that we named the School 5 as Miguelón, so there we discovered in Sima de los Huesos a complete pelvis, which we named Elvis. I think the relation is evident between Elvis Presley and Elvis the Pelvis from Atapuerca. But the most important conclusion of the morphology of this pelvis is that, and the channel of the pelvis that belonged to a man, that's for sure, was so high that a modern childbirth nowadays could go through it right now because it is very wide. So you can see also that the morphology and the hips were very, very wide compared to our species.
Well, the most famous of these finds is Skull 5, also known as Miguelón. Mario, can you tell us about this individual and why he's so important?
Well, actually, if you see face to face this skull, it seems to be like you can talk to this person because the skull is almost complete and it's by far the most complete skeleton in the Middle Pleistocene in the world. So it is a treasure that we discovered inside. It is true as well that this skull was not discovered complete. I mean, it was discovered in different fragments that later in the laboratory, experts were able to stitch together and to complete the puzzle with all or most of their teeth. So the key point in here of this particular skull is that we were able to go into their daily life, in the sense that we know that he suffered during life a strike. The reason we don't know actually, but the strike broke one of their premolars, upper premolars. So, and that breakage of that tooth created a very big inflammation and infection that went through the maxilla till the eye. So actually the depth or the width of the maxilla, it is much higher in that part than in the counterpart, the other side of the face. So this was a very, very big pathology, and we don't know actually if this caused the death of this individual or if it was uh, some perimortem. Perimortem, so in that sense, I mean, it might happen before the death of this individual, but in any case, he died with that infection fully in his face. That's why when we are able to see the reconstructions made by artists of this individual, they create this reconstruction with the face inflamed in the left side, and that's the reason. And now going to the naming of School 5 Miguelón, so it is a very curious situation. This story. So actually, this skull was publicly discovered and released in 1992 in July, right? At that time, the Tour of France cyclists were at the time during the excavation period. So in that year, one Spanish called Miguel Indurain won the Tour of France. And that's why, as an homage or in honor of this very, very important cyclist in Spain, scientists at the time, Arzuaga and colleagues, named this individual as Miguelón. It is incredible when you can see the real Miguel Indurain visiting the Museum of Human Evolution in Burgos, visiting and looking face to face to the School 5. So that picture is also very, very curious.
Found also were the remains of a teenage girl who has been dubbed Benjamina. Now, this is a very interesting find because, like Miguelón, she also had head trauma, but of a very different kind.
Actually, this fossil, this skull, another skull. Remember that at least we have 29 individuals in the Sima de los Huesos. This one in particular, Benjamina, was discovered at the beginning of the 21st century. So it's more recent than Miguelón in that sense. But the good point is that we were able to see the sutures of the skull bones, basically. And we know that this individual in particular, she was suffering from one pathology which is very well known in current population, which is craniosynostosis. So what does craniosynostosis mean? Actually, this is a very well medical pathology during the ontogeny and development of the individual. So the sutures of the skull, they suture prematurely. So in other words, so you know that the different bones of the skull, they are not fully stitched together because actually the brain needs to grow over time. If there is fixed suture between the bones, the brain cannot grow all the space it requires. So in other words, people suffering from craniosynostosis might have somehow some kind of mental disability. So what happened to Benjamina? She had craniosynostosis and it was somehow deformed the skull, and we are almost certain that she might suffer some grade of mental disability. So the question in here is, we know that she died at an age of about 16 or 17 years old. And the question is, how is that possible that this person 500,000 years ago survived? Obviously, because we are a very social species, and also were these populations from the Middle Pleistocene. So they took care of this individual, because otherwise she would have never survived until reaching the lines of adulthood. And this is a very, very good picture that can make us think about the healthcare in the past.
Well, the question we're left with is, why do we find so many individuals in this cave? Could they all have lived in the Sima de los Huesos, or could there be an even more intriguing reason?
We are not certain about which is the origin of such an accumulation. There are different hypotheses regarding the explanation of this big accumulation of at least 29 individuals, but the final hypothesis which has been tested is not yet in here. There is still discussion, although there is some kind of agreement inside the group. So it is important also to remark that in this small chamber, Sima de los Huesos, not only these 29 different human specimens were discovered, but also more than 100 skeletons of bears, lions, panthers, in other words, carnivores. So we don't have any fossils yet from herbivores, for instance. So this makes us think that this place was never used for a carnivore as the area to feed, actually, because in that sense we would have expected to find also herbivores somehow. It is not the case. The other situation that might point to an intentionality in the accumulation of bones by other humans, so the accumulation of human bodies by other humans, is that we only found one lithic industry, only one, which is a hand axe made of a very strange raw material in the Atapuerca hill, which is a red quartzite. And it is very rare, and it is a relatively complex method to create a hand axe made with this strange or weird raw material, and studies of the edge stated that it was never used. So, and we only found one lithic industry in the full Sima de los Huesos, complex, unused, and in a very strange raw material. So one hypothesis of the Atapuerca team was basically to say that this was introduced on purpose to commemorate or to celebrate or to remember this individual. So in other words, as a symbolic behavior, right? Not all of the scientists agree with this situation, but this is science. So we have evidence, and we also have rejections for those hypotheses. This is an ongoing debate, and it is very intense, depending on the scientists that are discussing about. In any case, there are other hypotheses, not only the intentional accumulation of bodies inside, but also a catastrophic event. For instance, one would expect in a normal cemetery nowadays, right, in a graveyard, is that the people we find mostly in these cemeteries are the youngest and the elderly people, right? So the youngest and the older. And the people in between those range are more rare in the cemeteries, and that's life, right? So what happens with the Sima de los Huesos bodies? So it's the opposite demography profile, because we find the people from 15 to 30 years, and the youngest and the elderly people are very are not that represented in the site. So which can be the explanation? So some scientists consider that this may be a catastrophic event, or maybe they suffer from a paleo epidemic. So, but in that sense, there is not a conclusive hypothesis to solve these unresolved questions.
And they are all what you call pre-Neanderthals, is that right?
Yeah, pre-Neanderthal, and that's a very important point, Mark. And I'm mentioning this on purpose. Let me explain you why. From the very beginning, the Sima de los Huesos fossils, they were attributed to Homo heidelbergensis because of the taxonomy rules that it was published Homo heidelbergensis at the beginning of the 20th century based on the Mauer mandible, and it was also Middle Pleistocene. So from the very beginning, the Sima de los Huesos fossils, as they were belonging to Europe and also to these Middle Pleistocene populations, they were automatically assigned to this species, Homo heidelbergensis. However, when more fossils were discovered over time, we realized that the morphology of different traits, mostly in teeth, so dental morphology, they were absolutely Neanderthal, and they were far distant from the Middle Pleistocene fossil discovered nowadays, like the Tautable fossils, Swanscombe, etc. So this means that there might be in the Middle Pleistocene two morphological populations in Europe. The ones which are more are older, basically from northern Pyrenees, so France, German, or English fossils, and contemporaneous populations in the Iberian Peninsula from Sima de los Huesos, that they were more Neanderthals than the equivalent at the time in Northern Europe. So that's why from some years onwards until now, from the Atapuerca team, we are now trying to reconsider the attribution of this taxonomical attribution of these fossils from Sima de los Huesos, and because we know that they are very, very Neanderthal-like in their morphology, not only in teeth but in other parts of the skeleton like humerus, femurs, etc. So we are a little bit conservative right now, and we prefer to name them pre-Neanderthals in contrast with the contemporaneous fossils from Northern Europe. So that's why in here we are somehow waiting to know if we are going to be defining a new species or we are going to be naming like pre-Neanderthals from now to the future.
Well, today, learning about human origins comes not only from the study of fossil bones, but from the extraction and sequencing of DNA. And the most ancient human DNA ever decoded was taken from a specimen found in the Sima de los Huesos. Isn't that right?
It is right if we consider human bones, because actually the oldest sequence of DNA in the world is from horses back to 800,000 years old, coming from the permafrost. But concerning hominins, it is undoubtedly the Sima de los Huesos fossils, the first ones ever recovered to date. In any case, and this is a very, very relevant question because we've been discussing all the time about bones, physical material. Actually, when we are going to the microscope, basically to the biochemical of the DNA structure, that's another story. It requires another techniques, methodologies to extract, etc. But from Atapuerca, from this Sima de los Huesos side, in 2014, it was published the first mitochondrial DNA from the Atapuerca fossils. And that was very, very interesting because at the time, there were plenty of Neanderthal sequencing of mitochondrial DNA published. So there was a direct comparison between them. And surprisingly, is that by studying this mitochondrial DNA, as researchers coming from the MaxPlanckSociety in Germany, they observed that the Sima de los Huesos hominins, they were more closely related with the Denisovans in Far East rather than with the Neanderthals in here. So that created, let's say, a big controversy because all the morphology of the bones pointed to a Neanderthal lineage back 500,000 years in the Atapuerca Hill rather than with the Far East Denisovan from Mongolia. So that was a very, very surprising result. It is true that these authors, they also acknowledged that by studying the mitochondrial DNA, it is a biased picture of the complete DNA. Actually, because the mitochondrial DNA is heard by the maternal lineage rather than the full father-mother genes. So, in other words, we were only observing this relationship based on these very small fragments of mitochondrial DNA from Sima de los Huesos. Importantly, is that years later, not only mitochondrial DNA was discovered, but also nuclear DNA, which is the core, the most important part regarding how the different organisms grow and develop over time. And the result of this very small fragment of nuclear DNA, which just for all of us that are listening to this interview know, is actually inherited by the father and the mother, so both together. It's not only uniparental. Pointed that they were more related with Neanderthals than Denisovans. So it seems that we still need to discover more DNA from these fossils to have like a much better overview of the relationships based on genes in this sense, because it is true that the latest results I read is that the percentage of DNA decoded from the nuclear DNA or from this Sima de los Huesos, it was 0.07%. So it is a very, very small fragment of the nuclear DNA. It is true that this DNA degrades over time very quickly, and it is fragmented in millions and millions of different small fragments. So it is complicated, but this research group from Germany, they are experts in analyzing these kind of evidences, and actually it was led by the Nobel Prize Svante Pabo, recently awarded. I think it was last year. So they all participated in here, and the results, to be honest, are absolutely impressive.
And also, Mario, I believe that the tooth enamel showed that the Atapuerca hominids grew at a different rate to modern humans. Is that right?
Yes, actually, I like to ask this question because that's part of my own research. So by studying this, the enamel and the dentin of the teeth, actually they are like time control. So they grow as the hair or the nails. So in a daily basis, there is a little of enamel and dentin created. In other words, we can count the lines of these tissues, and we can calculate the crown formation times of the teeth. And this is important because the development of an individual correlates the dental development with the maturation of the individuals. So if we are able to calculate the crown formation times or the dental formation time of this individual, we can have like a proxy, a window to oversee the growth of the past populations of hominins. In my research, I discovered that the average crown formation times of all the teeth of Sima de los Huesos was 25% faster than the average of modern humans. So my hypothesis is that they grew faster, Sima de los Huesos hominins, rather than modern human populations. And in average, the hypothesis specifies that they reached adulthood at an age about 14 or 15 years old, rather than the average maturity age in our species, which is about 18 to 20 years old.
And I know, Mario, that reminds me of a much older hominid in Africa, a Homo ergaster, a specimen called Turkana boy, who apparently had a incredible growth spurt and was very tall, but was actually, they found out, I think, from the teeth that he was only about 8 years old.
Yeah, you mean the Turkana boy?
Yes.
Yeah, so actually that was a study that was led at the time by my previous supervisor of my PhD, which was Christopher Dean, and he also got to the conclusion that although they were tall, so the growth spurt was very fast, and actually their maturation was also shorter than our species. So everything seems to be like aligned in the process of how we elongated our growth over time until 18 or 20 years old.
Mario, you must be very proud indeed to be able to work at Atapuerca and have access to such incredible fossils. Atapuerca is a UNESCO World Heritage Site, so what about the general public? Can people come to visit and see what goes on there?
The quick answer is yes. They can visit and they must visit these archaeological sites because in Burgos, the city where, and the province where the Atapuerca Hill is located, has different museums that are very suitable for people to understand the discoveries and understand how the middle and later Paleolithic hominins survived in the past. For instance, in Burgos City, we have the Museum of Human Evolution, where the people can see the real fossils. So you will not see a cast made of resin or plastic. It is the real fossil discovered in the Sima de los Huesos site. Miguelón is in there. The Elvis the Pelvis is in there. And concerning Miguelón, just for all of the people listening to us right now, very lately, not only the skull of this specimen is shown to the public, but also the 7 cervical vertebrae are attached into this specimen. So it's like little by little we are constructing the real skeleton of this individual. So this is concerning the Human Evolution Museum located in Burgos City. But also you can go with a very expert guide from the Atapuerca Foundation. You can visit the Atapuerca sites themselves. So you can visit the Cima del Elefante, Galeria, Grandolina, where Homo antecessor was discovered. And also we have extra options for the public, which is to visit the CAREX, which is the Experimental Archaeology Center, where experts and guides, also from the Atapuerca Foundation, they will give a quick overview of how to make fire with sticks and stones, how to paint on walls, how to create hand access. So in real time, and this is very, very amazing because you can see how these experts show you how easy or how complicated it is. And there is another option, which is the living Paleolithic, which is Paleolítico Vivo in Spanish, where you can do like a quick safari very close to the Atapuerca Hill as well, to visit a population of bisons which are living in here, and Przewalski horses. So and it is also very interesting. So in other words, Burgos and Atapuerca, it is very, very impressive for all the public that are interested in culture, in history, and in evolution.
It's been great having you back on the show, Mario, to talk about Atapuerca and the fossils of the Chasm of the Bones. I'm sure more amazing fossil finds will continue to be unearthed, and when they do, I hope you can return to Evolution Soup to share those treasures with our viewers.
For sure. So whenever new fossils are unearthed from all the different archaeological sites of the Atapuerca Hill, I will call you right away. No problem.